Okay, we're back here. On this video, we're going to look at the concept of a limit. We're required to have an intuitive understanding of this concept. It gets pretty heavy later on in higher maths for looking at the whole thing of a limit. I spent a couple years doing mostly thinking about this concept of limits and doing the mathematics around it. I really like it, this idea of a limit, and the whole idea of infinity, because that's what we're really going to be talking about. I want you to think about the first thing. Let's think about this thing. Say you were 10 meters away from a wall. Let's make it 8 meters. You're 8 meters away from a wall. If you could jump, if you could move half the distance, let's say you move half the distance of the wall, you'd be 4 meters away. If you moved another half the distance again, you'd only be 2 meters away, and then 1 meter, and then a half meter, and then a quarter of a meter, an eighth of a meter. If you could keep moving an eighth and a 16th and a 32nd and a 64th of a meter, you could keep doing that forever abstractly. If you had a distance, you could keep cutting it in half. Well, no matter how many times that distance would get cut in half, there'd always be something left. In real life, this wouldn't work. But abstractly, we could think, hey, I've become infinitely close to the wall, but I'd never touch it. That wall is called the limit of your moves. So the wall is the limit of of the distance being halved each time, but you'd never get there. Now, Mr. Autry, he's got another idea here. He says, what if you thought about a polygon, a three-sided polygon, which is a triangle, four-sided, five-sided, six-sided, seven-sided, eight-sided? Maybe there's something to notice here. That triangle doesn't look very much like a circle, but an octagon looks a lot like a circle. Well, a lot more like a circle than a triangle does. If I could make 16 sides, it would look even more like a circle. 1,000 sides, those little tiny pieces would be really small. The whole thing would look a lot like a circle. But if you made it 1,000,000 times, it'd be just about smooth to your eye. It would be smooth to your eye. And if it was 1,000,000,000,000 times, it would be, for all intents purposes, the circle is the limit of making the sides of a polygon. Now, there's another example here about limits. If you go y equals 1 over x, if we put in 10, we get a pretty small number, 0.1, 1/10. If we put in 100, we get 100, 1 over 100, 1,000, 1,000,000. The deal is, this number here, 1,000,000th, is pretty close to nothing. It's a very, very tiny fraction. If you put in 100 billion, 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 your number would be incredibly close to zero. The big deal is, as x gets bigger, y gets smaller, a lot smaller if it gets really big. Then we can say, as x approaches infinity in 1 over x, as x approaches infinity, then y approaches zero. Zero is called the limit of making the limit of 1 over x as x approaches infinity is equal to zero. Okay, so that's the big idea. That's all we have to understand. If this gets super big, 1 over something super big will be really close to zero. And you can imagine 1 over infinity is infinitely close to zero. And that's why zero is the limit. And that's our video on limits.